Okay, today we're going to learn how to factor trinomials, and we are going to use the grouping method that we learned from last time. So let's just remember a little bit. Remember, factoring means to undo multiplication or to break down a polynomial, and a trinomial is just a polynomial that has three terms. So we're going to be looking at polynomials that look like this: ax squared plus bx plus c, and a, b, and c can be any numbers. So for example, we could do 6x squared plus 11x plus 4. Okay, so let's actually start with that example. We'll figure out how to factor that one. So here's the steps that we're going to do. We're going to go through the steps, and then I'll talk to you guys about why those steps are the way they are. So my first thing I have to do is multiply a and c together. So a is the number in front of your x squared, and c is the constant. So I do 6 times 4, which is 24. Okay. Now I'm going to list pairs of numbers that multiply to get AC. So for example, I'm trying to look at numbers that multiply to 24. So I could do 1 and 24. I could do 2 and 12. I could do 3 and 8. 4 and 6. And that should be all of them. I could technically do like -1 and -24, -2 and -12, right? Because those would also multiply to give me a positive number. But I'm just going to leave them as positive for now. My next step is to find which pair of numbers add or subtract to b. So my b is 11. So I'm looking for which of these pairs of numbers adds up to b. And I noticed that this 3 and 8, 3 plus 8, is equal to 11, right? So that's going to be the pair of numbers that we're going to use. So what we're going to do with the 3 and the 8 is we're going to use it to split up our middle term. So I'm going to take it and I'm going to say, okay, I have 6x squared. And instead of writing 11x, I'm going to write plus 3x plus 8x, and then plus 4. So notice I haven't changed the equation at all, I've just changed what it looks like. So I've kind of just undone addition, right? Now I've got a 4-term polynomial. I'm going to factor it by, I'm going to factor it by grouping. So I'm going to split my polynomial up into 2 groups and factor the greatest common factor out of each group. So the greatest common factor of the first one is going to be 3x. What's left over is a 2x plus 1. Greatest common factor of the second group is a 4. I'm just left with a 2x plus 1. And then remember, I factor out the 2x plus 1. So the 2x plus 1 gets factored out. And I'm left with the 3x plus 4. Okay. So this is my factored form of this polynomial. Okay. So the idea is just once you split up that middle term, you can just factor by grouping. So the biggest thing is just deciding how to split up your middle term. So let's do some more examples of this. I'm not going to go through all these examples and let you go through some by yourselves, but let's go through a few of them. So we'll do A. First step is to figure out what's AC, or A times C. So 9 times 2 is 18. My B is 9. Okay, so I'm trying to find all the factors of AC, and then I'll decide which ones add up to 9. So factors of AC could be 1 times 18, 2 times 9, 3 times 6. Those are all of them. So then I look at these pairs and I see which ones add up to B, and I notice that 3 plus 6 add up to 9. So those are the 2 pairs of numbers that I'm going to use. So I'm going to use those 2 numbers to split up my polynomial. Okay. Once I have it split up, that kind of looks like a 61. That's a 6H. Once I have it split up, I'm going to do some grouping. Okay. Factor out the greatest common factor of each one. So I'm left with a 3H plus 1. Factor out a 2 from the second one. I'm left with a 3H plus 1. And my last step is I'm going to factor out the 3H plus 1 from each of these pairs. 3H plus 2. Okay, so that is my factored form. So if you feel comfortable with factoring by grouping, then the only real new thing you have to learn how to do is figure out how to split up your middle term B so that it's useful for you. Okay. Now notice that both the examples we did we were adding throughout, right? There was no negative numbers, and there's no negative numbers in our answers. So let's look at what happens when we start throwing negatives in. So let's look at C. So we're going to start kind of doing the same thing. So I'm going to have AC is 2 times 12, so 24. And then my B is negative 11 this time. Okay, I'm still going to list out the factors of AC, same as I would before. So I have 1 times 24, 2 times 12, 3 times 8, 4 times 6, right? And that should be all of them. Now, if I start looking at trying to add up these numbers, I realize that I'm just adding a bunch of positive numbers, and 2 positive numbers are never going to add up to negative 11. But what if I changed all of my numbers to negative? Notice that if I change all of these numbers to negative, then when I multiply them, I'm still going to get a positive 24 because the negatives will cancel out. So now I can look at these pairs of numbers and I notice, hey, negative 3 times negative 8 is positive 24, and negative 3 plus 8, negative 8, is a negative 11. So those are the two numbers that I'm going to use here. Okay, so I'm going to go ahead and split up my polynomial. Actually, I'm going to do this. I'm going to put the 8 first. I'm going to do the 3 first. Okay, and then I'm just going to do some grouping. Okay, so I'm going to factor a z out of this first set. And I'm going to factor a negative 4 out of the next pair. Okay, so 2z minus 3. And then factor the 2z minus 3 out. And that will be my final answer. Okay, so we have negatives in our original problem. We're going to see some negatives showing up later on. And if you want to check these, remember you can always check your factoring by just multiplying these together. So distributing all these numbers in and simplifying is going to allow you to double check and make sure that you actually factored it correctly. Okay, I want to talk about something else really fast. You kind of saw me going back and forth about if I wanted to put the negative 3z or the negative 8z first. Let's talk about the order. I'm going to switch the order here. I've already done it with negative 3z first. Now I'm going to switch it and do the 8z first and see if it matters. Okay? Start. I have it all set up. I'm just going to do some grouping. All right? So greatest common factor of the first pair is 2z, and then I'm just left with a z minus 4. Greatest common factor of the second pair is a negative 3. So I'm going to go with the z minus 4, because 12 divided by negative 3 is going to give me that negative 3. Then I have the z minus 4 in common, so I'll factor that out. And I'm left with a 2z minus 3. Okay. So note that it didn't actually matter what order I put my two numbers in. I was still able to get the right answer and the same answer. One thing that is interesting, though, is if you switch your order of like the 8 and the 3, then what ends up in your parentheses in your second step is going to be different. It's not incorrect, it's just going to be a little bit different. So if you and your friend work through the same problem, and halfway through you have different answers, but at the end you have the right answer and the same answer, that's okay. Okay. So we've looked at an example that had all positives. We looked at an example that had a negative b. Let's look at an example that has a negative c value. So let's jump down to g. Okay, we're going to do g. Remember, our first step is to do a times c. Look at this problem, and the first thing I think is, dang, those numbers are really big, right? 12 times 72, that's big. I don't really want to deal with that. So I'm going to see if there's a greatest common factor I can factor out before I even start. And I notice that all of these are divisible by 6. So if I divide all these by 6, I'm going to get 2y squared plus 5y minus 12. Okay? Now these numbers inside are a lot smaller. Those I'm way more comfortable dealing with, right? So I'm going to factor this the same way, and the 6 that's on the outside, it's just going to kind of hang out there to the end of the problem. So I'm going to start by multiplying my 2 times negative 12, my a times my c. So 2 times negative 12 is negative 24. So I've got to list all the factors of 24. I'm going to list all of them, just the positive, as if I was doing positive 24. And I'm going to remember that when I multiply two numbers and get a negative, one of the numbers has to be negative. So whenever I choose a pair of numbers, I have to make one of the numbers negative. So say I choose like 2 and 12 to be my numbers. Then either I have to make it negative 2 and 12 or 2 and negative 12. Okay? So remember, I'm trying to add up to 5. So I am going to choose 3 and negative 8. And I'm going to make the 3 negative. Because then if I do 8 plus negative 3, that gives me 5. Okay? And it's probably going to take some guess and check to figure out which pair of numbers you're going to use. Okay? So now I've decided how to break it up. I'm just going to rewrite this problem so I have 4 terms instead of 3. Then I'll go ahead and do some grouping. So I have the 6 that just kind of stays out front. I'm going to put it, oh, I want to change back to blue, I'm sorry. I have the 6 that's just going to stay out front. The greatest common factor of my first pair is 2y. I'm just left with a y plus 4. Greatest common factor of my second pair, remember this negative 3. I have a negative 3 out front, so I'm going to make that a negative 3. And then we're left with y plus 4 on the inside. Then my y plus 4s are the same, so I can factor those out. I'm just left with a 2y minus 3. So then this is going to be my factored form. Okay, so that's kind of how you handle that negative when your c is a negative. You have to make sure that you make one of your, when you find your pair of numbers, you have to make one of them negative. Okay, and you'll have to just look as you go throughout these problems, you'll have to take note of which numbers are negative, which ones are positive, and make sure that you're multiplying and adding appropriate numbers in every case.